Here we have some problems about finding the areas of composite shapes. And composite, that's a word that just means made up of several parts. So you'll see something like this where there's a rectangle and a circle. Now those are things you've probably been able to find the areas of before. If you forget a formula, you just look them up. I looked up a whole bunch of these on the internet and posted them up here so we'd have them handy. You probably remember the formula for the area of a rectangle. So this rectangle down here is 4 by 8. We just multiply the length and the width. So the area of the rectangle part of this is 32 square meters. Now we just have to figure out the area of the circle on top of it and add it to that. And that's the process with these problems. You find the parts, the areas of the parts, and you add them together. But this circle doesn't have a radius here. The area of a circle is the pi times the radius squared. What's the radius of the circle? Well, we have to infer it from this diagram. And if this length right here is 4 and the circle seems to fit in it, you can pretty much assume that the diameter here is going to be 4, which means the radius would be half of that, or 2. So the area of this circle is going to be pi times the radius squared, which is 2 squared. So let's get out our calculator and calculate that. So 2 squared is 4 times pi. That's 12.566. And let's just go ahead and do the next step. We'll add 32 to it. So that's adding the circle and the rectangle. And we get 44 well, let's round to the 100th, 44.57. And this is square meters. All right, here's a slightly more involved one, but you can see again, it's got a rectangle in it, and then it's got 2 half circles, which is really one whole circle. So really this problem and this problem are pretty much the same, except this is a field and they want you to find the cost of fertilizing the field, and they have a cost of fertilizer. So there's an extra step. We need to find the area of this thing, and then we need to multiply it by this cost per square yard to get the total cost for fertilizing the field. All right, it says the rectangular part of the field below is 110 yards long. So this line, this length right here is 110. And it says the diameter of each semicircle is 46 yards. So this side is 46. So our rectangle is 110 by 46. And let's figure out the area of that. So that's 5,060. Now let's figure out the area of this circle. Area is the radius squared times pi. The radius is half the diameter, so the radius is going to be 23. So that's 23 squared, squared, times pi. So let's figure out that part. So 23 times 23, and multiply that by pi. So that's the area of our circle. And let's go ahead and add the area of the rectangular part. I think that was 5,060. So that's our total area of this shape. Now we want to find the cost for fertilizing, so we multiply it by the cost per square yard. So that's 50 cents or $0.5, so times 0.5. And we get $3,360.95. That's a lot of money to spend on fertilizing a field. Let's try a couple more. This one looks a little bit strange. It asks us to find the area of this shaded region, and this shaded region is a shape that we don't have a formula for. So how are we going to do this? Well, really, this shape consists of 2 shapes, a square and then a circle inside it. And if you want to find the area of the shaded region, imagine that the circle has been cut out of the square. So really, we take the area of the square and we subtract the area of the circle. Well, the area of the square is not too hard here. It's got a side of 18 centimeters, so that's just 18 times 18, or 18 squared. And the area of the circle, well, we're given the radius, so this is pi times the radius squared. So we can pull out our calculator for that. So let's see, let's do the circle first. So 4 squared is 16, and we multiply that by pi. So that's the area of our circle, a little over 50. And we want to subtract that from 18 squared. So I'm going to go ahead and add that to memory, and we'll be able to recall that later. So let's figure out 18 squared. 18 times 18, 324. And now I'm going to subtract, recall the memory. Hopefully that works. Yep, looks like it works. So we have an area of 273.73, and our units here were centimeters, so this is square centimeters. Of course, area is always square units. All right, one more. So this creature looks like we've got, I suppose you could break this up into triangles and a rectangle and a semicircle. Really, this whole bottom piece here is a trapezoid, and the formula for the area of a trapezoid is not too hard. I've got this back on that last page. So a trapezoid, there it is. It's 1/2 the height times the added together of the two bases. Really what they're doing, you're taking the top and the bottom of that trapezoid and you're taking the average of it. That's base 1 plus base 2 times 1/2, or divided by 2. And then you multiply that by the height. So that's the formula for the area of a trapezoid. We'll use that. And then we've got half of a circle, a semicircle here. So we'll use the formula for the area of a circle and just multiply it by 1/2. And this one, we have these multiple choice answers, and we don't even have to do a ton of calculation here because they're keeping the area of the circle part in units of pi and keeping the area of the trapezoid separate. So let's start figuring out the area of the trapezoid. When they say base 1 plus base 2, here's base 1, here's base 2. They're the parallel sides. So we're going to have 30 plus 16, and then we multiply that by 1/2, which is the same as dividing it by 2, and then we multiply all of that by the height. And our height is 14. So let's just put that in there. So that's our whole calculation for the area of the trapezoid. Let's see if we can figure that out on the calculator. So 30 plus 16, then we're going to divide that by 2, and then we multiply by the height, which is 14. So that trapezoid is 322 units, and you can see, we've got a couple of answers with 322 in them. Let's figure out the semicircle now. So the semicircle, we're going to have 1/2 because it's only 1/2 of a circle, and then pi times the radius. The radius, well, we've been given a diameter here, so the radius is half of that. So the radius is 8, and it's the radius squared, so 8 squared. So let's see, 8 squared is 64, so this would be 64 pi inside there, and 1/2 of that would equal 32 pi. So we found 322 for the area of the trapezoid and 32 pi for the area of the circle. That's what we've got right here in answer choice C. So that's a little bit of work with the area of composite shapes.